All right. So in the previous lecture, the internet was cut off while I was trying to discuss this particular example. Okay. So who would like to read this example for us? Maybe I should do it. So suppose that a mortality investigation covers the period 1 January 2015 to 31st December 2017. So again, we are looking at, so you should, ideally, you should have a look at how many years that we are considering. So you might be tempted to just see that this is 2015 and this is 2017, but we should remember this is 1 January 2015 and this is 31st December 2017. So from 15 to 16 and then from 16 to 17. So 2 years. Then in this investigation, the age label that they use is age last birthday. So I guess we have studied 3 different definitions of age, and they are using age last birthday. And this table has all the information that these people have. So we are observing 3 particular lives, and we know each of their date of birth and the date of joining and the date of exit. Only for this particular person, we don't know. So now they want to use this data values to determine the range of dates for which these lives contribute to EXC. This is nothing but exposed to risk at age X, where they make a contribution. And again, they are just assuming that the day of entry counts in the exposed to risk, but the day of exit does not. So, okay, now okay, so the very first thing that we want to do is we want to figure out at what ages people do join in for our investigation. So we have these people's date of birth. So, and I guess also I would want you all to determine the ages of this person, and this person when they have joined. And again, remember, you should use the definition of age last birthday. So let us say, for example, here this particular person is born in 83 in April. And here we are looking at January. So according to you, what do you guys think his age would be using the definition of age last birthday? Anyone? So let us just do it for the A guy first.
Would it be 31?
Okay, just give me a minute. Actually, this is not working good. All right. So Vanshita said that this particular person, A guy, will be 31 years old. Yes, that is indeed correct. So let me just draw the timeline first. Okay. And again, the date when we start our investigation is what? It is 1 January 2015, right? Okay. So what I will do first is I will just write here that this is 1 January 2015. Okay. And then I know that I want to look up until 31st December. So this is, let's say, 31 December 2017. Okay. And now this particular guy, A guy, is 31-year-old on 1 January 2015. Okay. And So what are we asked to do? What we are asked to do is we have to figure out the contribution to EXC of each of these lives. So let us say if you're looking at the A guy first, we want to see what all ages this A life lives for throughout our period of investigation. So we know that this particular person is 31-year-old, right? So this person is 31-year-old on the day we start our investigation. All right. But then we know as when April will come about. So let us say if you're looking at here, and this is, let's say, 25th of April, 2015. So this guy will be 31 only up until this particular time, right? Then after this particular instance, this guy will turn 32 till when? Till 25 April 2016, right? And then again, we will have one more stop, which is 25 April 2017. So this guy will be 32 up until this, and then 33, and then 34. Does this make sense? Yeah, so we have determined the age of A guy. Okay. So these are the ages of A guys at this particular point in time. But now we also know that the guy didn't really stay with us throughout the whole period of investigation. On 30th October, this A observation exited our investigation. So where do we get this particular time, which is somewhere in between here, right? So somewhere in between here, we have 30, 10, 16. And this is when this guy have the exit. All right. So all we know is we have observed this particular person starting from this to this point. So we know that this A person has been 31-year-old, 32-year-old, and 33-year-old during the times for which we have observed this particular person. And these are respective dates when this person was 31, 32, and 33 respectively, right? So again, they have said that the day of exit does not count, which is why we have written 29 here and not 30th October as we would have. So this was for the A guy. So you see that this A person contributes to 31st age, 32nd age, and 33rd age, right? So whenever we want to figure out exposed to risk for these particular ages, we know we will have to count the A guy for 31, 32, and 33. So we will do the same thing for our B as well. But again, what do we know about B? We do not know the date of exit. I mean, we have no reason for the exit as well. So again, what you will do is you will just figure out his date of birth when he joined. So you will figure out using his date of birth, the age at which this particular person has entered the observation. And it will turn out to be 33. And if you see up until the end of the observation period, you see that life B has contributed to the age 33 and age 34 of the exposed to risk for, let's say, age X last birthday. And the similar thing you will do for the C guy for times whenever you see that particular guy being in the investigation or the observation periods. Okay, so now let us try to do something else. So, Mihir, can you read this question for us?
Yes, ma'am. Now suppose that we are using the age label age next birthday. Give the range of dates for which the lives in the table above contribute to E34.
Yeah, so central exposed to risk for age 34. But again, what we are looking at now is age next birthday, not age last birthday. So what do you guys think this question is asking us of? First of all, how is this question different from what we have just done in the previous question? What do you guys think? So, and the very first thing that changes is the age definition that we are trying to use, right? So in the previous question, we used the definition age last birthday, but now what we are trying to use is age next birthday. And all they want to know is that out of these lives, what is the range of deaths for which this particular lives contribute to ECX, where X is 34. So maybe what will help us is to go back to our definitions of age here. So now if we see, the only difference between age last and age next is that if I say that my age last is X minus 1, my age next for the same time will be X. So if I'm saying that my A guy is 31-year-old for this time interval, using the age last definition, I can say that this particular person is 30, so we said 31 here, right? So this has to be one more than this guy. So this will be 32, right? So here we will have 32 here according to the age next definition. So the very first thing that we can do is, what I feel is easier is to just convert these numbers. And so if we just remember that if we look at age last, and if we have X minus 1, this is equivalent to X for age next, right? So now these are age last birthdays. So if this is 31 for age last, this for this particular time interval, this person is going to be 32-year-old using the age next definition. Do you guys agree with this? And for 32, I'm going to have 33. And for 33, I'm going to have 34. And similar thing for this person as well, 34, 35, 35, and 36. And the question asks us to see the contribution to EC34. So we will have these dates and we will have these dates. And for C guy, there are no dates. So this life C does not contribute at all to EC34. Again, when we use the definition age next. Does this make sense to all of you? So maybe I can just do this. So if we go back to the question, what the question asks us was, now suppose that we are using the age label age next birthday, and instead of age last, now we are using age next. So the very first thing we did was to go back and see the relationship between age last and age next. So whenever I say that I am X minus 1 year old, using the age last definition, this is equivalent to saying that I'm X year old using the age next definition, right? And which is why if I said here that I'm 31 year old using age last definition, I just have to add 1 here, and this will be my age according to age next definition. And that is what we do for all of the times that we have observed here. And because again, the question asks us to figure out the contribution to EC34, we only care about these lives when they age 34. So here we have these dates, and for B, we have these dates. And for C, there is no date at all. So we do not observe life C whenever that life is 34-year-old using age next definition. Any doubt? Anyone? So I want you all to take like a couple minutes if you still want to understand what's going on here if you do not. And just a thumbs up or a yes if you have understood this, so that I can know that you have understood this.
Understood.
Okay. And what about others?
Yes, ma'am. Understood.
Yes, ma'am. Got it.
Okay, perfect. All right. So this is again, so For us to now figure out exposure to risk is easy. You just have to measure this in terms of months or in terms of days or in terms of years. And you know these starting dates and ending dates, starting dates and ending dates for each one of these. Okay, but again, life is not this easy always. So sometimes what happens is you do not know these values. So again here, what happens normally is whenever you are, let's say, an insurance company and you want to record the premiums that people pay. So let us say there is one particular date on which, everyone is supposed to pay the premium, or at least a particular date when these people have, a full record of. So maybe what they can do is they can decide that on 1st January, we are going to take a record of how many lives are still continuing in the policy, or so basically how many dates have been happened up until in this year. So you don't see or you don't record each death that you observe throughout the year. What you do is you just let the other people record each death, and then you just ask them a particular number. How many people died in this year? And you just write off that number on 1st December. On 1st January. So now you only have information on 1st Jan of each year that you're looking at, right? So you will not necessarily have information, to be precise, you will not necessarily have the precise information about the actual date when these people died, the actual date when these people joined, or the actual date when these people left the investigation or your observation period. So now what you will have to do is we'll have to resort to some sort of approximation. So again, the kind of approximation that we are going to use actually has a particular name, and it is known as census approximation. Has anyone heard of census? Does anyone know what census is?
Counting of the population, right?
Exactly right. So we basically count the population at some particular instant in time. So time is also very important here, and we are just counting the population. So here what we will do is, because we are looking at, some approximation for the calculation of exposed to risk, which is again, just the counting of number of people that are exposed to risk at a particular point in time. And this approximation is known as census approximation because we're looking at a count of people at some time. Okay, so now let us say I observe people on 1 Jan 2016. I observe people on 1 Jan 2017. Okay, so if I have this information, so let us say I plot here on y-axis, and the number of people on 1 Jan were these many, and the number of people on 2017 were, let's say, these many people. So I know that I have these many people exposed to risk, and these many people exposed to risk at this point in time and at this point in time, and that could be any number here. So not to, I'm just trying to avoid too much of notations in here. All right, so once we have this, now if I ask you to tell me how many lives or what is my exposed to risk at 1 June 2016, how will you answer this question? Because you haven't observed anything at that point in time. So what you do is you make a census approximation. And when I'm talking about census approximation, the thing that you do here is you say that we expect a linear relationship in here. So again, this is some census data. This is another census data. But this data I have never, calculated precisely. But what I do is I just create a line here, a linear line, and I expect there to be a linear relationship between this. So now I will just take this up, and whatever number I get here will be, my approximation for EXC at this particular point in time. Okay, but now if I want to do this, I would want to know a method to figure out this particular point, right? How can I figure out this particular point? So because now this 1 June, let's say is in middle of these 2 points, you can just take an average, because again, this is one linear line. And if this is your point A and if this is your point B, and the distance here is 0.5 and here is 0.5, in proportion, this is just 1 to 1. So this particular point will just be A plus B upon 2. Do you guys agree with this? Do you guys agree with what I have written on the board here?
Yes.
Yes, okay, perfect, right? So now whenever I'm talking about my exposed to risk, I always specify a particular age, right? So I will specify a age, let's say X, and that is the age I want to figure out exposed to risk for. Now, as we know, with any kind of definition of age, there is 1 year span of time when you stay the same age, right? So here, if I'm starting, let's say, from 1 Jan 2016 and from 1 Jan 2017, and if a person is, let's say, just staying for the same age, I know that this X here is this whole period. So this whole period is the time when a particular life is aged at X. So now if I want to figure out the central exposed to risk, ideally, what will be my formula? It will just be integration from some time to some time, which is, let's say, if I'm looking at only 1 year. So let's say this will just be 0 to 1 and pxt dt. So what I mean by pxt dt is the probability that any person who is alive. So again, what does my pxt here denote? So again, whenever I'm talking about pxt, I'm changing my t here, right? So what I'm trying to do is I'm trying to integrate. So I'm trying to basically take the whole area under this trapezium from 1 January 2016 to 1 January 2017. And my pxt measures the lives, the number of lives that are, alive at each of these point in time. So what I'm trying to do is just adding up these. So to figure out my actual exposed to risk. Okay, but again, now do we always have all the information? No, so this integration seems a bit difficult to figure out. So again, I mean, because it's clear, right? We only know the pxt at px0 and px1, which is when this person is at 1 Jan 2016 and on 1 Jan 2017. And nowhere in the between we have any information about the values that pxt takes. So now what can we do? So what we do is we use these approximations that we have just studied, which is, so basically this is known as trapezium approximation, because if you look at this shape that this particular thing forms is something similar to a trapezium. And if we want to figure out the area for this trapezium, does anyone remember the formula for the area of trapezium? So if I want to figure out my area of trapezium, it is nothing but base, which is this particular length, times a half of the sum of this length and this length. So basically, in a way, so again, so just to give you guys some general idea or a way to remember this area is, let us say if you're looking at the area of a square, what we do is we square the sides. If you're looking at the area of a rectangle, it is length times breadth. So now if you're looking at the area of trapezium where these two lengths are not equal, you just take the average of these two lengths and you multiply it with the base. So average of these two lengths is just going to be a plus b upon 2, and you multiply that with the base. So here again, now whenever I'm talking about the base, it matters if I'm measuring time in numbers of years, in numbers of months, or in terms of days. So generally in actuaries, we will use years, right? Because people change their age from some year to year. So for 1 year, whenever that might start, they stay at the same age. So our base will be in years. And these will represent the number of lives at each of these starting and ending point in time. So now if I were to approximate, so now I want to generalize this thing. So what I say is I have some death data. Let's say, so I have dx, which represents, the deaths of people. And so the number of deaths aged x last. So let's say if I'm using age x last definition during calendar years, k plus 1 and so on, so up until k plus n. So this is one thing that I observed, and the other thing that we will observe is definitely px comma t. So this represents the number of lives, not probability anymore. So the number of lives under observation aged x last birthday at time t. Yeah, so whenever now if we are talking about pxt, generally it is specified that my t is 1 January, which is when the valuation for companies happen annually. So they don't sit and do the valuation every day within the year, right? They'll do it at one specific date in a year. And we're assuming that it is 1 January. So in years, so again, calendar years, k plus 1 and up until k plus n plus 1. So now if you see here, we have these data up until year k plus n plus 1. Why? Because if I have to measure 1 year, I know I start in 1 Jan 2016 and I have to end up at 1 Jan 2017, which is 1 year later, right? So if I know the information about the number of deaths in k plus n year, that will correspond to somewhat k plus n plus 1. I mean, from k plus n till k plus n plus 1 year, the number of lives that were alive will correspond to this particular number of dates that you would have observed in this particular year. Okay, so now once we know this, now I'm going to generalize this thing. So here instead of 0 and 1, what I can write now is that I observe this thing from k up until k plus n plus 1. So this is a very important formula. And this is your precise formula to figure out your central exposed to risk. And this uses integral. And we know that, okay, this is not very convenient for us. Just give me a minute. Okay, so now this is what we have for our definition of central exposed to risk. But as we know that this is not quite possible for us to figure out. So what we do is we use this approximation that we have just studied, the trapezium approximation, and we will try to use that to redefine this particular thing. So let me just see if I can reduce this size. Yeah, so these are again just, the definitions of dx and px. The ones that we're going to use. All right. So now what I will do is I will just redefine this particular formula for central exposed to risk. So I do a trapezium approximation. And now what I do is I try to write this particular information in terms of these points on which I observe the PXT. So if I want to figure out something about this, I can just take an average of these two, right? So what I can write here now is for any PXT, I will look for, again, summation, because we are looking at discrete times now, and we do not observe PXT in continuous. So we only observe this on some particular date in each calendar year. So we observe this from K to K plus N, and we'll have for the formula here, Px comma T plus Px comma T plus 1. So here, if you want to do some approximation, this is saying that you do remain age at X, but you take an average from time T to time T plus 1. And that in general will summarize your PXT. And you take a summation. So this is even more important. And this is the definition that we will use always. So I hope this is making sense to you guys. Any doubts up until now? Anyone?
Ma'am, why do we have the alternate formula like the one that you wrote in green?
Okay, why? And that's a good question. Because see, here what I have to figure out is integration of PXT for every time my T changes from K to K plus N plus 1, right? So let us say this is my 0 and this is my 1. So my 0 represents 2016 and my 1 represents 1 Jan 2017. So if I want to figure out my actual exposed to risk, I need to know how many lives were alive at every single time, at every single day during this particular year. And I don't have that information for every day. I only have that information for one day in a year, which I think represents, the whole of the year. So again, whenever we're counting the population of a country, right, we don't sit and measure the population of the whole country every day in a year. We only measure it, let's say, on 1 January. And we will say that, yeah, India's population was so and so for this particular year, right? And we assume that this particular number that we have now wrote for the population of India is true for the whole of the past year. And approximately it is fine. So that is the same thing that we do here. The number of lives that we have under our observation, age at X, under the definition of age last birthday, we only know that information on 1st January of every year. So to build an approximation, sometimes if we want to figure out the mortality rate, right? So if we want to figure out mu of, let's say, 31.3 or 31.5, how will you figure that out? You will need to know the exposed to risk and dates for those particular times, right? And that is why we need this particular approximation, which only uses the observations that we have made. So we observe PXT, we observe PXT plus 1, we observe PXT plus 2, T plus 3, T plus 4, right? So in my definition of PXT, I've written that T is 1 January. So the only thing that's changing is the year from K to K plus N. So you start with PXK plus PXK plus 1. So this could be, PX 2016 plus PX 2017, and that will be divided by 2. So we know we have observed A and we have observed B. So this will just be A plus B upon 2 for this particular year, 2016 to 17. Does this make sense to you now, Isha?
Yes, I'm understood. So basically, we've just substituted the PXT and PXT plus 1 in the trapezium formula, the area of trapezium.
Exactly.
And base is 1 because we are considering it for 1 year.
Yeah, so we are considering it for one whole year, which is, so again, we will always measure our base in terms of years. So let us say if I want you guys to now give me the exposed to risk from January till June, then we will just have something from 0 to 0.5. So in integrals, you will have 0 to 0.5, not 1. And here as well, instead of half, so here I have half of this multiplied by 1. So multiplied by 1, which is the base. So now my base will be 6 upon 12, right? Because I've observed this only for some 6 months. So you will have this thing multiplied by 6 upon 12. Now I haven't, because I'm looking for one whole year from T to T plus 1, right? These are the two things that I have. So maybe what I can write here is you multiply this thing with, T minus T plus 1 minus 1. Oh no, not like that. Yeah, t plus 1 minus t. Yeah, so that you only get a 1 here. So this represents difference in the times in years. So again, because we always measure this thing in years. Okay, perfect. I think this is good. All right. So now once we know this, let us try to do some example where we will use this particular concept. And I think yeah. So this is it. All right. So now what they have given us is some information. So to illustrate how the census approximation works, we will now use it to estimate PC55 from this data. So I have calendar year and I have population aged 55 last birthday on 1 January of each of these years. So what do I know? If let's say I plot a number line for 15, 16, 17 and 18, I know how many number of people were, so again, aged 55, last birthday, were alive on this point in time, which is let's say some 46, then you have some 42, then again you have some 42, and then you have again some 42. So let us say this is some line that you will get for this people aged 55 in each of these years. Okay, and now what we need to figure out is the value of this thing. So central exposed to risk at age 55 from 1 January 2015 to 1 January 2018. So again, in terms of integrals, whenever I start my observation, I will call that year as 0. So I think the best way to see this thing is just write 0, 1, 2, 3 here, and then you can start your k from here, k plus 1, k plus 2, and so on. So my 0 will be 1 Jan 2015. So I'm looking at 3 years, right? 15 to 16, 16 to 17, and then 17 to 18. So let me just erase this thing. So now what we're looking at is an integral from 0 to 3 for P55, T dt. Does this make sense to you guys? So again, whenever I'm talking about, the years that we are observing, so my first year will be 1 Jan 2015 to 31st December 2015. Then the second one will be 1 Jan 2016 to 31st December 2016. Then I will have 1 Jan 2017 to 31st December 2017. So again, I just only have 1 Jan 2018, which is 1 day at next. So if I'm measuring from January to January, 1st Jan to 1st Jan of each of these, I have 3 years, right? So that is why in my integral, I have from 0 to 3, P55, t, where my t changes every time from 0 to 3. But again, as I know, I only observe this particular t's when I have 0, 1, 2, and 3 as the number. So let me just take a different color and maybe I can just write it here. So 15 represents 0, this represents 1, this represents 2, and 18 represents 3. So if I have something like this and I only know information at 0, 1, 2, and 3, what I can do is now I will try to use the approximation formula that we studied. So you will try to approximate this thing as summation, again going from 0 to 2, and what you will have is P55, t. So let us say my t is going from this, plus P55, t plus 1, and a half of this. So this will give you the average. And with the base, I know that the difference between this is again 1. So I observe my lives after each year. So this is just going to get multiplied by 1. So now if I expand this particular thing, I get something like this. So 1 by 2, P55 0 plus P55 1 for my t taking the value 0. Then t will take the value 1 and then your t will take the value 2. So that way you have 1 year, second year, and your third year. So that is why you have 3 terms here in the summation. Does this make sense to you guys? Any doubts so far?
So ma'am, that is like for 0 and then 1 and then 2.
Yeah, so basically 0 to 1 is 1 year, 1 to 2 is second year, and 2 to 3 is third year, right? The way we are denoting this.
Like why have
So,
we written their summation from T0 to 2?
Yeah, because so again, if you write this thing from 0 to 3, you will have here P55.3 plus P55.4. But do we know 4? We don't have any information about 2019, right? So that wouldn't make any sense. And again, so what happens in summation is you're trying to figure out these. So 1 year, 2 year, and 3 year. In integration, because it is continuous, you are saying that this is from 0 to 3. But in discrete, you look at particular points in time, right? So you look at from
ma'am,
0
I'm
to
saying,
1.
so 0 to 1 is denoted by 0, 1 to 2 is denoted by 1, and 2 to 3 is denoted by 2, right?
Yes, yes. So again, remember what we are trying to do is, we have observed this, and this. And what I try to do is, I say that these are linearly. So there is some, so these behave linearly. Even though I don't know what is happening here, I say that this is happening linearly. So maybe let me just show you guys something which might help. So let us say if I'm looking at something from this to this, maybe let me just, erase this thing and just save this. So what I will do now is new share. All right. So let me just try to show you guys something which might be helpful. So all right, I have this bad. Okay. So let's say I have this trapezium, something here, and then I observe some other thing here. And if I want to figure out the whole of this thing, how do I do it? So what I'm doing now is, if this is A, this is B, I take a point here and I say that this is A plus B upon 2, right? This is the kind of approximation I'm making. But in a way, what I am trying to do is, I complete, so I just take these rectangles and I'm trying to, sum them up. So what I do is, I create a middle line here in between. So at the middle point of this particular line, I create a horizontal line. So now what I do is, I measure the area under this. So now what I just do is, I measure the area under this rectangle. So I measure this much of area. And if you see, I'm losing some actual area here and I'm taking some extra area into consideration here. But I assume because there is a linear line here, this and this will be the same, right? Because this distance will be same and this distance will be same. And then you have these angle properties. So by the congruence, you will see that this particular triangle area and this particular triangle area are same. It doesn't seem as though in my diagram, because this is not the middle, but yeah, this is the idea, this is the general idea. And that is why now if you just take this particular point and this particular point, so if you see this height, which is this, represents the height of this particular rectangle, and then base is this. So this height is what? A plus B by 2. So this is just A plus B by 2, and this is your base. So the area of this rectangle would just be height times the base. Does this answer your doubt, Isha? So this whole area under the trapezium, I approximated first with this rectangle. And to figure out the height of this rectangle, I know that this cuts at the middle point in here, which is just A plus B upon 2, because I'm joining this with a straight line. So you multiply that with the base and you get the area of this rectangle, which is your total exposed to risk at a particular age. So now if I go back, my writings are gone, but yeah, if you now have a look, let me just maybe draw the timeline again. So what we had was 15, 16, 17, 18, right? Now for this particular 1, 2, 3. So these are 3 boxes that I care about, right? So I will figure out this area, and this area. So this area will be this. This represents this area, and this here represents this area. Does this make sense?
Yes, ma'am.
Okay. 2 others. Any doubt? All right. So now once we have approximated this thing, the only thing left for us is to put in these values, because we know what is P550, we know what is P551. So P550 will just be this 1, 2, and 3 will take respective values. And once you substitute in these values, you will get your answer for the exposed to risk at age 55 for the lives that you have under observation. So this is how you will try to figure out. And let us just try to do this question again. And now I want you all to try to solve this. So Savri, can you read the first 3 lines of the question?
Yes, ma'am. The disreputable insurance company, Honest Mutual, had met the fortunes in the year 2018. At both the start and the end of the year, 547 policies were in force in respect of the policyholders age 40 last birthday. But these figures do not tell the whole story.
Okay, so what do you understand from this, Savri? What do you think the first 2 lines are trying to say?
And that the whole year there were no one surrendered or no one withdrew the policy, died in the policy.
Are you sure about that? So all we know is at both the start and the end of the year, 547 policies were enforced. So all we know is that at, let's say, 1 Jan 2018, we had 547 policies, and on 31st December, we still had 547 policies. But
And we can say that the net additions are 0.
Yeah, yes. So you can say that the net additions throughout the year is 0. Very good point. So Isha, can you continue reading the next of the question, the next 4 lines?
Yes, ma'am. There was adverse publicity early in the year linking the company's investment managers with a gambling syndicate. As a result, many policyholders took their money elsewhere. Following a successful marketing campaign offering a free toaster to all applicants, the number of policyholders aged 40 last birthday rose from 325 at 1 June 2018 to 613 at 1st September 2018.
Yeah. So now if we see, we know that, let's say at 1 Jan, we had 547, and at 31st December, we had 547. But in June and in September, the numbers changed, right? They did not remain constant throughout the year. So we know that at 1 June, we have 325, and on 1st September, we observe 613. Okay, and now what they're asking us to calculate is an approximate value for the central exposed to risk at age 40 last birthday for the calendar year 2018. So now you not only know what has happened at the start and the end of the year, but also something about what has happened in between the year, right? So ideally, if we weren't calculating its central exposed to risk, if we were, let's say, suppose looking at only the initial exposed to risk, for the whole year 2018, we would have just said that 547 is our exposed to risk, right? These are the number of lives that we are observing. But as we know that that is not the whole story. So there have been some fluctuations. So we will try to figure out whether my central exposed to risk is, okay, so even before doing this calculation, what do you guys think? Will the central exposed to risk be higher or lower than 547? Can you guys say that with the information that we have? Will my central exposed to risk be higher or lower than initial exposed to risk?
Maybe lower.
And why do you think lower?
Because at 1st June, it was like the figure was 325, which is much below 547. And then it rose to 613. So 325 is like almost 200 figures down, and 613 is only 100 figures up. So
Yeah.
maybe we
So
can
that
say
is
that
actually a very good thing.
yeah.
That is actually, I mean, you are thinking on the correct direction. So we expect that our central exposed to risk will be a bit lower, right? So let us try to figure out and let us try to see how will we figure out our central exposed to risk in this particular situation. All right. So let us, we have this particular space. And the very first thing I find helpful to do is to draw a timeline and see what all information do I have. So if let's say I start drawing a timeline here. So let us say this is my 1st Jan 2018. I know 547, then 1 June 2018, 325, then somewhere 1 September 2018, 613, and here I have, let's say, 31st December 2018, and this is again 547. All right. So if I have this information, now again, I know that each of this information is corresponding to the 40 last birthday. So we don't have to check, whether we are looking at people aged 40 or not, because all the information is about people aged 40 last birthday. So that's good. Now, if I were to write the definition in terms of integrals for thing that I have to figure out, that will be E40C, right? And again, I only look at 1 year, so from 0 to 1, and this will be P40, T dt. But again, as we know, we do not observe P40T for anything in between here. So we'll have to make some approximations from this to this, then this to this, and then this to this, right? Now, if we were not given this information, then we will just, we would have just taken middle in between this, and what you would have gotten is 547 itself. But now that we have some additional information, we try to use this. And the way we are going to do this particular thing now is to figure out the area from this to this, then this, and then this, and add them up all together to get to our final answer for central exposed risk at for 40 last birthday. All right. So again, we know bases do matter. So in previous cases, my base was always 1 year. But now if I'm trying to measure this distance in terms of years, I know the months that I have passed are 6, right? So what I will have here, oh no, not 6, I haven't passed my June. So again, this is something that you should always try to remember, right? 1 Jan, 2 1 Feb, 1 month, and so on. So till 1 June, you only have 5 months. Then from 1 June to 1 September, how many months do I have?
3.
3, right? So here I have 3, and here how many months do I have? 4, right? Minus 12. All right. So these are the number of months that we are looking at. So again, converting these in terms of years, this is my base length now for this, and this. Okay, so now maybe what you can do is you can try to even ignore the whole formula that we have studied, but all you have to do is just imagine a trapezium here and try to figure out this value. So using this as your base. So the area for this distance will be something like, 5 by 12, which is your base, times the number of people you observe here, 547, plus the number of people you observe here, 325 upon 2, right? So this will be your exposed to risk for this point in time. And you can do the similar thing for each of these other 2 as well. But I think if you do not see this very clearly, all you will have to do is try to use the approximations and everything. Okay, maybe I shouldn't do this first. Save it. Yeah, so maybe what might help you otherwise is to actually first convert the integral that is given to you in terms of the times at which you have all the information. So from 0 to 512, you have some p, from 5 to 8, you have some p, and from 8 to 1, you have some p. So this represents these three intervals that we're looking at. And now you will make the linear approximation for this, this, and this. So again, if you are, very peculiar with the, if you want to do the whole of the writing, you should do it like this. So 5 by 12 is the difference between these integrals. So upper limit minus the lower limit is what you will get here, because that is what represents the times, right? So here you see 5 by 12, 8 by 12. So you get 3 by 12. 1 minus 8 by 12 is just 4 upon 12. And these numbers, so now if you see here, you do not have p plus 1. You have p plus 5 upon 12. So again, because we know these numbers now, we can easily put in and get our value for the central exposed to risk. Any doubts so far?
So the final figure, it denotes that on an average over the year, how many people were exposed to that risk.
Yes, yes. Aged 40 last year. So not every people, but people aged 40 last year.
Yes.
Any doubts? Anyone? All right. So I mean, I know this could be a bit confusing. This is not at all difficult once you get your basics clear, and if you can read what is being asked in the question very clearly, then you would know how to approach these questions. And I think you can see it for yourself whether you find doing this directly helpful or going through the whole formula and stuff helpful, and you can decide for yourself. So I guess,
ma'am, in this case, will it be compulsory to like split it and write like the integral? They have split it and written, right? So instead,
it's
can
not
I just
necessary.
can I just write the integral and then the summation thing that we did?
Yes,
like earlier?
yes, you can do that. You can do that. So, okay, one thing that you will have to remember is if you're 100% sure about what you're doing, you can skip from this to this. So, if you get the correct answer, you can draw a diagram to show what you're doing, because even the examiner should understand, how you're splitting the integrals. So, it's not compulsory to write this form. But again, you should always remember that if you write this form, if you make any mistake here, so you might be, you might not be that severely punished, because then the examiner would at least.
Exam is online, so drawing the diagram will not be possible, right?
Not exactly, right? You can just draw a line in the Word. So, oh no, I think you guys are not even allowed to use the drawing tool, right? Yeah. I don't know, maybe if you can just, so what you can do is you can plot a vertical line. You can actually just draw a table, so whatever I have written here in horizontal, you can write everything in vertical. So you can write these dates, and then you can write these numbers, and then you can write this times. So again, it depends on how you try to convey your information, and you have freedom. So you can choose to draw a diagram, you can choose to not draw the diagram. You can draw the diagram just for your benefit in the book that you might be using, and then write this thing directly. So I think if it's a computer exam, whenever you try to write your answers, the very first time you write all the answers, you should not do it very methodologically, I feel. This is what I would do. And I would just make sure that I at least finish all the questions first. And then I can go on and, if I see that I have some time left, then I can write this equation for this question, let's say, because this equation will certainly take up a whole lot of time. And what might help you is to do more questions. Again, only if you're confident about, the other question that you're solving. Otherwise, you should do one question fully nicely so that you get all the marks that are being assigned. But yeah, I guess So that was it about this particular kind of questions. Okay, so up until now, what we saw was there was no much, difference in the kind of classifications of age that we were looking at. But what can sometimes happen is that, as I've already discussed, I guess, before, that let's say the death department. So the department which handles the death data might use some different definition of age than the department which handles, the exposure. So in that case, if you have two different age definitions being used, you will have to convert your data of exposure to suit to the death data or the definition that people might have used in death, in recording the deaths. But again, if we see, you might ask the question, why can't we convert the death data to, suit the definition of the exposure data, which is again just, the principle of correspondence. So the question is of, what is much more easier and also what makes much more sense. So we know that, census or exposure data is much more extensive than the death data, and it is in fact even more regular than the death data. And your DX, which is the death, is actually subjected to much more random variation than your exposure, which is why it always helps to just convert the age definition of death and exposure to whatever we have used to record the deaths. So now we will try to see. So again, now what I'm going to use, in your books, they have just represented. So if you see here, they have represented DX2. So previously we only had DX, which represents the total number of deaths, age X, last birthday. So if you have DX2, it means you are looking at age nearest birthday. And if you have DX3, that means you are looking at age X next birthday. And then they define something known as rate interval. So before we do that, I want to do something else. Okay, so now we saw this nice principle of correspondence, and I want to shift everything, let's say somewhere here. Yeah, so that I can get some space here. And now what I'm trying to do is, so I will use age last. So I'll use age last, and I have age nearest, and I have age last. And now what, age next. All right, and now what I'm trying to do is just create a nice table which will help us. So in the first, I'm going to write some rate interval. Then I'm going to write my estimate for mu hat. Then I'm planning to write my estimate for Q hat. So now if you see my Q hat here, uses the initial exposures definition, and my mu hat will use the central exposure risk definition. So now the very first thing when I'm talking about rate interval is nothing but, the period of 1 year when your life does not change the age. So if I'm talking about age last, all I can see here from my diagram is that from X minus 1 to X, this person remains the same age, X minus 1, right? So my rate interval for this thing will be, okay, so again, just to be in coordinates with the book, I'm going to use from X to X plus 1. So we see that the age remains same. So ideally in the books, they have given square brackets, but I'm going to write this thing as this, because I know that once I am at X plus 1, I attain the age X plus 1. So I'm no longer X year old. And if I'm looking at age X nearest, every time I am aged X, so if you see, what are the times when I can call myself being of the age X? So that starts at X minus half and ends at X plus half. So I will again do something like this here, X minus a half and X plus a half. And if I'm looking at age next, the time when I'm aged X is X minus 1 to X. So all I will have here is X minus 1 to X. Okay, and to be precise, this should be a curly bracket. Okay, and now if I'm talking about this Q hat, this denotes, the initial exposed to risk. So this, for this particular interval, will just be QX. So if I'm talking about QX, it represents my age last from X to X plus 1. And if I'm talking about QX minus half, this is the interval that I correspond to. And if I'm talking about Qx minus 1, then this is the interval I'm corresponding to again with these respective definitions. And my mu hat represents the central exposed to risk. So what I will do is I will just add up these and divide them by 2. So 2x plus 1 by 2, which is nothing but x plus a half. Then here you will have mu x, and here you will have mu x minus a half. So these are the estimates that you will get for these particular definitions of age. So again, each of these correspond to a simple definition of X. So everywhere in this, we have assumed that my person is aged X. So if this person is aged X and we are using this definition, and if I want to figure out mu X plus half, this is what I will have to use. This is the interval that I will use. And similarly for rest of these mu's and rest of these q's and these rate intervals, and this is the age. So remember, this is only one age, but we have 6 different definitions. 2 based on if we're looking at initial or exposed, initial or central, and the 3 depending on the 3 definitions of age that we can use. So any doubts with this chart of the diagram? Anyone? Any doubts? Am I audible? Can you guys hear me? Hello?
Yes, ma'am, it's clear.
Okay, yeah, because my phone got locked. Okay, so no doubts. All right, so this is a table which will be, very helpful. So again, this table is nothing but just a very nice and crisp summary of whatever we saw here in the diagram. So again, we were looking at people aged X. So from X to X plus 1, then X minus 1 to X, and then X minus a half to X plus half, right? And then we look at central exposed to risk. So middle of these 3, and if I'm looking at initial, then QX minus a half, and then QX minus 1. All right, so now we will try to solve a question which will use this knowledge. Yeah, so we have this question for us now. Vanshita, can you read this question for us? Vanshita, are you there?
Yes, ma'am. Suppose that an investigation into mortality covers the period 1 January 2017 to 1 January 2018. Time is measured in years from 1 January 2017, and PXT denotes the number of lives at time T, aged X next birthday. The following data have been recorded for each X: DX, number of deaths, aged X next birthday, and Px of 0 and Px of 1. Explain which values of mu can be estimated using these data values, and this can be done. How this can be done.
Okay, so what do you guys think is being asked of us here? What is the information that we know? So try to read the question again if you want to in your own mind.
We know the number of people alive at those particular dates,
Yes.
and also the number of deaths during that period.
Very good.
So we can figure out the mu x minus half.
Yeah, and how did you get to that, Isha? Can you tell us?
Because we know the age next birthdays, right? So according to the table, the mu estimate will be mu x minus half.
Exactly right. So very good. So what we are looking at is aged X next birthday. So the formula that we'll be using is again dx upon exc. And for X, the rate interval will be defined from X minus 1 till X. And if I have to figure out mu for this particular interval, then that is just going to be mu of X minus half. Very good. So this was easy. Now let us try to do something else. So again, here they have just defined that you represent your px comma 2 as the number of lives, blah, 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 under the definition of age x nearest, and px3 denotes age x next birthday. And let us try to ignore everything and dive into the question. All right. So Mihir, can you read this question for us?
Yes, ma'am. A mortality investigation covered the period 1st January 2017 to 1st January 2018. Time is measured in years from 1st January 2017, and PXT denotes the number of lives alive at time T and age X, last birthday. The following data were recorded for each X. DX denotes the number of dates, that's age X next birthday. Obtained an expression for the central exposed to risk in terms of the available census data that may be used to estimate the force of mortality mu X plus F.
Oh, so I shouldn't show you guys the answers. All right. So I'm not going to say a single word here, and I want you all to figure out what are we supposed to do. Okay. So maybe there's something else that I should really tell you guys. Okay. So whenever we are trying to, just use the trapezium rule for this thing, we get some another value, right? By doing this particular half and this approximation that we make. So sometimes you can just denote that approximated value. So again, why have I written X here? Because from X minus 1 till X, this person is aged X years, right? So I can just say that this is my approximated value for Px comma T. And I put a hyphen here. I put a apostrophe S here, and that will just tell you that this is just approximated value. So, all right. Now let us try to do this. What do you guys think I should be doing next? I mean, what do you guys think is the information that is given to me, and what am I asked here in terms of your own words? Yeah, I'm back. Okay, yeah. Did someone say something and I missed? Anyone? Are you guys still understanding the question? So what is the definition that I'm using here to record the death? Am I audible? Hello?
Yes, ma'am.
Okay, yeah. Can someone say hello to just check? Hello?
Ma'am, your voice is echoing slightly.
Oh yeah, I don't know. Just okay, yeah, I guess now it's better, right?
Yes, ma'am.
Okay, perfect. Yeah, thank you very much. All right, so what do you guys think about this question? What is the age definition used to record the deaths here?
Age next birthday.
Very good. And what is the definition used to record my number of lives? So exposure, which is PXT.
Last birthday.
Age last. Right. So we use age next and age last, right? And I guess the easiest conversion is whenever we are asked to convert from age last to age next, or vice versa, because either you will have to add one or you will have to subtract one, right? So, okay. The very first question asks me to figure out some approximation for the central exposed to risk for mu x plus f. And yeah, so what do you guys think we are being asked here? So the very first thing that we'll have to do is we'll have to make sure that we are approximating the exposure data that we have in terms of age last to age next, right? So if I have PX0 and PX1, I need these definitions for so basically I need these particular two numbers to match with the data, and because I have this as age x last, I need to convert them into age x next, right? So what can I do now? What do you guys think? So maybe I can show you guys up until here. Yeah. So the very first thing that we do is write this in integral form, and then you approximate it using the linear thing, right? So whenever I'm writing here with the apostrophe s, what I mean apostrophe is, I mean that this is the definition of exposure at time 0 for a person aged at X using the definition of age next birthday. So now if I were to write this P dash X0 in terms of PX0, what do you guys think? How can I do that? Anyone? So my this thing here represents using age next, and all the move is PX0, which uses the definition age.
Ma'am, your voice is echoing again.
Oh, again. Let's get into this. Is it better now?
Yes.
Okay, perfect. So now what do you guys think this relationship is like? How can I rewrite my px0 to suit the age next definition? So basically all I need to know is that is there a way for me to write this particular term in terms of this term, which I have some information about. So here I have p dash x0. So this is for a person aged at x age using next definition, right? So all I know is maybe we should go back to this chart here. And if I see, I know age next. If age next is x, then the thing that corresponds to this particular time interval is x minus 1 for the age last definition. So now if I go back here, what do you guys see? How can you draw the relationship between this thing, which is age next, and px0, which is age last? So all you can do is convert this thing into age. So let us say if I have here, okay, so you shouldn't start with this, because what we want is to write this thing in terms of what we have information about, right? Is my voice clear to you guys, or is it still echoing?
It's clear, ma'am.
It's clear. Okay, very good. Yeah, so I want to rewrite this thing in terms of what I have some information about. But this uses the definition age next, and this is age last. So maybe what I can do is I can try to convert this thing first. So if I write my p dash x0, what does this thing tell me? This thing tells me about the number of lives that were alive, x age next birthday, and time 0, right? So I can convert this age next to age last definition. So if I know that a person is aged at x using age next definition, what will be the person's age again at the same time using age last? It's going to be x minus 1, we just saw, right? So this person will be aged x minus 1 using the last definition at time 0. So these are all equivalent to each other. And this I can rewrite as p x minus 1, 0, right? Using this notation here, just the age is different now. So just with this very little approximation, I can rewrite this thing. So I can rewrite my p dash x0 as px minus 1, 0, which is, so this is in terms of age last, and this is in terms of age next. And now because you have made these approximations, you still continue with this definition and you rewrite this p dash x0 as px minus 1, 0. And similarly, you will do the same thing for px1, and here you will have px minus 1 at time 1. And you will do a half of it. So this will be your recorded census data for aged X in terms of age next birthday. So even though you had information about the exposure data in terms of age last, you converted that to age next. And then you try to figure out the relationship between this age next with the age last that you know. So that with the information that you have, you can figure out the value of this particular thing. So now you have to not look at the X, but X minus 1 year for your age last. And then again, now for the value of F, all we know is that the definition that we are using is age next. So here, using that, you will have to determine the interval that you are looking at. So can someone tell me what should be the value of F here? So basically, what is the mortality rate that I will be figuring out? So my person is aged X from X minus 1 till X, right? And the central exposed to risk for that case is mu x minus a half. And that is why you will have your f as taking the value of minus half. Any doubts with this? Anyone? Any doubts so far? Okay, so I'm taking that as a no. And now what we should try to do is figure out some end of the chapter questions. Okay, so now maybe what I can do is, I want you all to try this 9.2 on your own. And let us do this in the class itself, just to get the idea fixated. Okay, so who will volunteer to read this question? Anyone would like to volunteer, or should I call upon someone? Savri, can you read this question for us?
Yes, ma'am.
I want you to read 9.2.
You have been given the following census count for the population covering all ages. Estimate the central exposed to risk for this population over each of the following periods using only the census count pre-2016, pre-2017 and pre-2018. In each case, state any assumptions you have made.
All right, so whenever we are talking about the assumptions, you will always have to assume the linearity, right? And that is the very crux of the approximation that we are trying to make here. All right, so now we only have information for 1st January of each of these years, and we need to figure out the central exposed to risk for the 4 periods that they have given to us. So the very first period is from 1 January 2016 till 31st December 2017. Okay, so what is it that I can do here? This is easy, and let me just do this. So I have 2016 information, I have 2017 information, and I have 2018. So everything is 1 Jan, all right? So I have some 20,000 people here, some 40,000 people here, and then some 30,000 people there. So something like this. All right, and you can just join it here as well. A very nice tent. Yeah, so if I want to figure out things from 1 January 2016, which is from here till 31st December 2017, which is till here, right? So basically everything. What I'm going to do is just take a half of this and a half for this interval, right? So I will create some rectangle here in half. I will create another rectangle here in half and try to add up those. So let me just go back here to the answers. Yeah, and if you see here, what they have done is 20, 40, 30. So 20 plus 40 and a half of that, and 40 plus 30 and a half of that. So now that is in total you are exposed to risk for these 2 years. All right. So the next time period that we have is from 1 July 2016 to 30 June 2017. Okay. So my 1st July 2016 will, let's say, lie somewhere here, right? So 1st July, and then I have 30 June 2017. So it was again gonna lie somewhere here. So 30 June 2017. So if you see, this is clearly, the middle, and this is again clearly the middle, because 1 July and 30 June, so 6 months and 6 months from January, right? If you count. So again, if you want to measure the exposed to risk from this to this, we need to know this number and we need to know this number as well. And we already have information about this guy. So we can do one approximation from this to this, and then another approximation from this to this. But to do that, we need to know this A and this B. So how do you guys think I can determine the values of A and B here? Anyone?
A plus B by 2.
Exactly right, which is what we have already done here. So we got 30 here and we got 35 here. So we already know this, and then we can just approximate one here and then second approximation here to get the central exposed to risk from this to this, right? Which is what we care about here. So let us see what they have done. Yes, they have done similar, right? So 30 plus 40 divided by 2 and 40 plus 35 divided by 2. But there is one catch. Now the base is not equal to 1 for this and this time period. So you have to take into consideration that this is only 6 months. So you not only multiply this average, but you will have to multiply this average with a half, which is your base, right? Which is no longer 1 year anymore. So because you're looking at half a year, so you get this half and this additional half every time you try to do the approximation. So you will have this half giving you the value here, and then this half trying to take into account the 6 by 12 here on the x-axis with respect to time. Does this make sense to each one of you? All right, so now let us look at the third question. So in third question, what are they asking me? From 1 January 2018 to 31st December 2018. Okay, now this is weird, right? Because we only have information about 1 January 2018. So all you can say here is that either it remains constant throughout the year up until 31st December, or that you cannot say anything about the exposure to risk. So yeah, this is some boring question, but yeah, just to basically show you guys the limit of the calculations that we are making. So our calculation is very good if you want to figure out the exposure to risk from anywhere between 2016 up until 1 Jan 2018. But after January 2018, you have no idea what's going to happen. So you can either just assume that it's going to stay constant, but again, this approach would be very, very unreliable. All right. And the next thing that they're trying to ask us is from 1 April 2017 to 31st March 2018. So again, you will just make assumptions about these base, not exactly, so assumptions about the linearity, and then you will try to consider in the months and so on. So I want you all to separately try to figure out this particular value from 1 April 2017 to 31st March 2018. So what is it that I should write on the board here? What do you guys think? Anyone? What do you guys think about this?
We can figure out the 9 months part, but again, after Jan 2018, we don't have any data. So we won't have any basis for that, like for the last figure.
for the 31st March 2018, right? Okay, so what is it that you can do? You can just assume that it stays, 30 throughout that time period, right? Yeah, so similar thing you're gonna do, and from this to this, you can just take, so first you only have 3 months from 1st April 2017. Oh no, so what you're gonna do is you have data from 1st April till 31st December. So you'll count those 9 months. So 9 upon 12 will give you 3 upon 4. And then for the next term, you only count in 3 months. So January, February, and March. So 3 by 12 will give you 1 by 4. And you assume that it stays constant. So you assume that it stays at 30. And this is the value that you will get. All right. So that was it about this question. Now let us try to do this question. So 9.3. Who would
The
like to read
screen
this?
is frozen, ma'am.
The screen is frozen. Oh, again, some internet. Oh, no. I paused it myself. Now can you see? Yeah. So let us have a look at 9.3. So Isha, can you read the question?
Can you repeat what you said, ma'am? Sorry.
Oh, I said, can you read the question 9.3?
A mortality investigation was held between 1st January 2016 and 1st January 2018. The following information was collected. The figures in the table below are the numbers of lives on each census date with the specified age labels. During the investigation, there were 42 deaths at age 49 nearest birthday. Estimate mu 49, stating any assumptions that you make.
Okay, so we have to figure out the value of mu 49 here, right? Okay, and the definition for age we use is age last birthday. For exposed to risk and for death, we have information about 49 nearest birthday, right? So we'll try to convert whatever we have in age last to age nearest. And then try to use that to figure out mu 49. But again, my very first question is, if I want to figure out mu 49, under the definition of age nearest birthday, what is the interval that I'm looking at? So you go back to the chart here and you see the definition that we're using is age nearest, right? And what we are trying to figure out is mu 49. So what you have to look at is 49 minus half and 49 plus half interval. So this is how you will know what you should try to have a look at in here. So again, what do you guys think should be my first step here? So I already know my B49, right? My mu 49 is going to be just B49 upon EC49, right? Now I know my D49, but I will have to figure out my EC49. And how can I do that? So we know information about, people's birthday and basically their age on these respective dates. And I want to figure out EC49. So how can I do that? So maybe the very first step that I should do is to write that I want to figure out EC 49, right? And my mu of 49 is just going to be B49 upon EC 49. So remember, not always your mu x will give you dx upon ECX. Because we're looking at age nearest, this is the case. But if you're looking at age last or age next, then these mu x will not be. I mean, this could be mu x plus a half or mu x minus a half. But again here, because we're looking at age nearest, yeah, we get my mu 49 as B49 upon EC49. And this is just 42. And I need to know the value of this guy here. So maybe the very first thing that I can do is use my integration symbol here. And how many years am I looking at? 16 to 17 and 17 to 18. So if I term this thing as 0, I'm going till 2 years, right? And again, I know that these numbers that I have observed are P, X, comma T, right? So X corresponding to these ages and T corresponding to the times. So 0, 1, and 2. So now what I can do is, instead of writing P49T here, which will be in terms of age last, I know that I want to figure out my exposure in terms of age nearest birth date. So what I do is I define this P-49T as my age nearest definition for the lives that are alive at age 49 and at time T. Okay, so now how do you guys think I can figure out my value of this particular thing here? So what do you guys think I should do next? So now if you see anytime these kind of questions, it is always helpful to go step by step. So let me just clear everything here. And let me just show you guys how these questions are actually solved first, so that you guys get some idea, right? So first we will write the definition of EC49, which is what we want. So this is from 0 to 2 P-49T dt, right? And then what I do is I try to just divide this linearly from, so okay, maybe I should, okay, let me just do it. They've skipped some steps. Okay, so what we want to do is we want to figure out the value of EC49, which I think is represented in such a manner, P-49, comma T and dt. All right, so now I can write this linearly as from 0 to 1, P-49, comma T dt plus integration 1 to 2, P-49, comma T dt, right? And now if I want to make approximation for this guy, what will I have? I will have P-49 at time 0 plus P-49 at time 1 and everything divided by 2. And the year I'm looking at is 1 minus 0, so multiplied by 1 as it is, which I'm not going to write here. Plus, this will be a half of P-49 at time 1 plus P-49 at time 2. And now if you see, we have a half of P-49 one here and a half of P-49 one here. So all you can do is rewrite this thing as something like this. Does this make sense to you guys? Any doubts so far? So now once we do this, we actually get to know what P dash values do we need to figure out, right? So now we need to figure out P dash 49 0, P dash 49 1 and P dash 49 2. And the very basic thing that we can do is now, so what is my exposure data in terms of? It is in terms of age last, right? And I want these to be in terms of age nearest. So let us see what is the difference? So if I go back to this, all will be erased. So what I'm trying to do now here is just maybe create some line here. X minus 1, x plus 1. And if I'm looking at last, I'll be aged x, and here I'll be aged x minus 1, and here I'll be aged x. And if I'm looking at nearest, I'll be aged x here, x plus 1 there, and x minus 1 here, right? So now you guys tell me, how can I figure out this particular value? P dash 49, 0. So again, if we go back, we have information about 48, 49, and 50, right? So we have P48, P49, and P50. So what do you guys think should be happening here? So basically what I can do maybe to make this thing a bit easier is substitute in ages here. So if I'm looking at someone aged 49, I want this information, right? So my X here is 49. So I know that if I want to convert whatever information I have for age last to this, I want to look at this time interval and this time interval, right? So if my X is 49, this will be 49 and this will be 48, right? So basically what you want to do is do some sort of average between 48 and 49 here. Does this make sense to you guys? So, or maybe if this seems a bit difficult to you, you can just derive a particular relationship. So if I have this thing, what do I mean by this? Is that the number of lives alive at time 0 and aged x using the nearest definition, right? And if I were to equate this with the age last definition, what will I have to do? So if I have my x nearest, I know that I'm looking from this time till this time. And I know that there is no one age that it covers if I'm from trying to see my end answer in terms of last age. So I will have to take some approximation between x minus 1 and x here. Does this make sense to you guys? I don't get a yes and I don't get a no either. So now I'm confused whether you guys are understanding what I'm trying to say or not. So please try to respond. So what I basically am trying to say is that if I have P dash x0, where my x represents x nearest, if I were to write this in terms of age last, so remember when I'm writing dash, this means that my x is using x nearest. So what I can do is I can just rewrite this thing as px minus 1, 0 plus px0 and take the average. Because I see that for the times when I say that my person is aged x, using the last definition, the person is neither x minus 1 nor x throughout this whole period. Half of the times this person is aged x minus 1 and half of the times this person is aged x. So that is the kind of approximation that I'm trying to make here. So now if I have to figure out my value for this guy, I can rewrite this particular thing as a half. So this half is this half, but this whole approximation will be just a half of P48 0 plus P49 0. And we know these values, right? P48 0 and P49 0. So these values will be this and this respectively. Oh no, sorry, this and this, 48 and 49. So this and this respectively. And because the time is 0, we are looking at 16. So the same thing is going to happen with this particular guy here, P-49-1. So to figure out P-49-1, you will add up this number and this number. And to figure out P-49-2, you will add up this number and divide each of those by 2. And then every time you just have to substitute in these values and you will get your answer. Any doubts, anyone? So maybe I should write this. Just what is the value of P48? It is 3486 and 3450. Yeah, so this is what you will have for this red arc. Still, I don't have either a yes or a no. No one is asking me any doubts, so I'm really confused as to whether you guys have understood this or not. So the floor is open. If you have any doubts, ask me right now. And this is it for today from my side.
Understood.
Okay, so maybe what you guys can do is try to solve the rest of the questions on your own. And if you have any doubts, just feel free to ask me. Okay. And I think the 9.5 part is very nice because over there you have some mismatch. So my mu x is not equal to dx upon exc because that happens only if you use the age nearest definition. Otherwise, it's going to change. So let me just save this and now clear everything. And so, okay, maybe you guys can, okay, just try these questions on your own and let me know if you have any doubts. So I'm going to stop the recording now.